Okay, so let's walk through number 5 first. So number 5 is awesome. It looks like this. And the first thing I did was, say I have two different trig functions. Well, that's not going to fly. So I had to change the sine squared into a cosine. So I used my Pythagorean identities that says sine squared x plus cosine squared x equals 1. So sine squared x equals 1 minus cosine squared x. So instead of writing this sine squared right here, I replaced it with my 1 minus cosine squared. And then I distributed my 2, and then I combined like terms, and then I divided everything by a -1 because I don't like this leading term to be negative. And then I used factor by grouping. So 2 times 1 is 2. You need 2 factors of 2 that add and give you -3. Well, -2 and -1 multiply to give you 2 and add to give you -3. So then I rewrote that -3 cosine x right there as a -2 cosine minus another cosine, because when you combine them you get back to right where you were, so you haven't changed anything. Now my first 2 terms are a group and my second 2 terms are a group, hence the name factor by grouping. These first 2 things have a 2 and a cosine in common, leaving me with a cosine x minus 1. And these 2 have a -1 in common, and I knew to pull out the negative because I have to have a cosine x minus 1 here in these parentheses, because this parenthesis and this parenthesis have to match. That's how you know you did factor by grouping correctly. So now both of these have a cosine x minus 1 that I can pull out, leaving me with a 2 cosine x minus 1 right here. 2 things multiplied together equaling 0 means each piece equals 0. So this piece equals 0 or that piece equals 0. Then we solve. We add the 1, divide by 2, so cosine equals 1/2. And we add the 1, so cosine equals 1. Cosine equals 1/2, you should have told me pi over 3 and 5 pi over 3, but the restrictions on this problem were -2 pi to 2 pi, which means I get to go forwards around the circle once and backwards around the circle once. So 5 pi over 3 when you go backwards is called -pi over 3, and pi over 3 when you go backwards is called -5 pi over 3. So when you write your answers for this one, nicely enough, we can write plus or minus pi over 3, comma, plus or minus 5 pi over 3. Comma, we're going to add in some more answers here. So then I took my other piece right here, cosine x minus 1, added the 1 over, so cosine x equals 1. Well, cosine equals 1 right here, which is 0, which we also can call 2 pi and -2 pi based on my restrictions. So 0, comma, 2 pi, comma, -2 pi, or you could have put a plus or minus right here, and it all would have been the same thing. That was a lot, I will admit. So if you got that right, kudos to you, you're doing a really great job. If you got a little bit stuck along the way, it's okay, we're just working through it. Okay, number 6 was a lot easier. So the hint on the side of your paper on number 6 says, try squaring both sides and using a Pythagorean identity. Moving this sine over or this cosine over isn't going to do you any good because you can't change the sine or the cosine to match so that you only have one trig function. What you want to see in paper is a square, because you know how to change sine squared into cosine and you know how to change cosine squared into sine. So we square both sides. When you square both sides, don't you dare distribute this and think that it's going to be cosine squared plus 1. No, no, no. That'd be way too easy. That's not how math works. You have to actually FOIL this out. So when you FOIL it out, you get cosine squared plus 2x plus 1, 2 cosine x plus 1. And I'm going to change this sine squared into 1 minus cosine squared. And I'm doing that because I have cosines over here, and the whole goal of this was to have one trig function. So I change it, and then I move both these terms to the other side. So you end up with 2 cosine squared x plus my 2 cosine x, and when you move this one over, they go away. So now you look at these two things and you try to factor. Well, they both have a 2 cosine, so I pulled out a 2 cosine, and in the first term I'm left with cosine x, and in the next term I'm left with just a 1. 2 things multiplied equals 0 means both pieces equal 0. 2 cosine x equals 0, or cosine x is going to equal -1 because I subtracted the 1 over, making it a -1. 2 cosine x equals 0 divided by 2 cosine x equals 0. Cosine equals 0 up top and down below, so it's 0 at 2 pi and 3 pi over 2. Sorry, not 2 pi. Pi over 2 and 3 pi over 2. And then cosine x equals -1, cosine equals -1 over here at pi. Since you had a restriction, those are your only answers that you're allowed to have. So x can be pi over 2, pi, and 3 pi over 2. And all I did was write them in ascending order. So hopefully you're getting an idea of how this is working. You now need to go to page 10, which is all simplifying, and you need to have page 10 done for class tomorrow. If you have any questions, either post them on Edmodo or make sure you're at tutorials.